Okay, in this section, exponential functions, we're going to look at solving exponential equations. So I have a couple of examples here and we'll work through them. So in this example, we're asked to solve 81 to the x minus 2 power equal to 27 raised to the negative x plus 4. Now the way we solve an exponential equation, in other words, how we get at these variables, is to use the one-to-one property of functions, of exponential functions. And let me write this out to the side here. A one-to-one function is one that's such that if f of a equals f of b, then we know, if this is the case, then we know that a equals b. So that means equal inputs lead to equal outputs. Functions that are not one-to-one do not have this property. Stuff like x squared could have two different inputs that lead to the same output. Anyway, if a function has this property, then what we can do is if we set up, especially exponentials, if we have a situation like this, so we have a to the x equal to a to the y, then we can immediately write x equals y. Okay? Because if this statement here says that the outputs from this exponential are equal for both a to the x and a to the y, therefore x equals y. Those inputs, the x and the y, those exponents must be equal. So to solve an exponential equation like this, what we want to do is set it up like this, so that both of the bases on each side are the same. Once they are, we can set the exponents equal to each other, and that will free up the x and we'll be able to solve. So let's see if we can do that here. We have 81 and 27. And you might notice that both of these are powers of 3. For example, 27 is 3 cubed, and 81 is 3 to the 4th power. So we can replace the 81 and the 27 with their appropriate powers of 3. So we'll take 81, and we'll notice that that is equal to 3 to the 4th. And 27, we'll notice that's 3 to the 3rd. Okay, so we'll put in 3 to the 4th right here. 3 to the 4th raised to the x minus 2 equals 3 to the 3rd raised to the negative x plus 4. All right, now we can use a property of exponents. That is, if we have a base, we raise it to a power, then we raise that to a power. We can simplify that by multiplying the exponents. So 3 to the 4th raised to the x minus 2 is going to be equal to 3 to the 4 times x minus 2 power. And similarly here we have 3 to the 3rd raised to the negative x plus 4. This is going to be 3 raised to the 3 times the quantity negative x plus 4. Okay. Now we've written this equation with the same base on both sides. And since exponential functions are one-to-one, we can set the exponents equal to each other. So we have 4 times x minus 2 equals 3 times negative x plus 4. And now we can solve the equation from here. So we have 4 times x minus 2, that's going to be 4 times x. And then 4 times negative 2, negative 8, equals 3 times negative x and 3 times 4, plus 12. All right, we'll just solve this. We can add 3x, add 8. We have 7x equals 20, and so x is 20 sevenths. All right. let's look at another example. We have 3 to the x squared plus 4x equals 9 to the x squared, 9 to the negative second. Here we have a really shorter route to having the same base on both sides. We've got a 3 here and a 9, and we know 9 is 3 squared. So we have 3 raised to the x squared plus 4x equals 3 squared raised to the negative second. So here we have 3 raised to the x squared plus 4x. And then these can be combined. We have 3 to the negative 4. Same base on both sides. Exponents must be equal. So x squared plus 4x equals negative 4. Right? And now we have a quadratic, which we can solve. This will factor, I believe. We have x and plus 2 plus 2. And so the answer to this is negative 2.